Okay, like all of you, have you revised? Yes or no?
Yes, so.
Garvit, have you revised?
Yes, sir. I'm just on the ending part.
Okay, Jivitesh. Jivitesh,
Yes, sir. I'm just going through. Yes, sir.
क्लास के पहले रिवाइज कर लिया करो यार.
Sir, last class we ended on structure of diamond, right?
Yes. So to show you methane, okay, I told you something in the last class. I told you that it is non-planar. So methane is like this. If you see, are you able to see, visualize?
Yes,
Yes,
sir.
sir.
It's not planar, okay?
So, like, is there a way you could type C60 and see what comes?
Yes, let's see.
It was Buckminster Fuller. I guess.
So it got confused.
But yeah, great.
Sure, but this is like plain.
Yeah.
So isn't this supposed to be like a sphere?
Yeah.
Yeah, exactly.
Why is it a circle?
And so then I don't think so. It was a legit 60.
1, 2, 3, 4. 4. 40. No, I mean with the same formula, different compounds can also exist, right?
Yeah. So let me snap. Ongo. So which app is this?
Repeat.
Which? Oh, mall view. Okay. Yeah. Okay.
Check the spelling, no? Buck.
So it's BUC.
Oh.
So
What?
could you rotate this one?
Fail to resolve a 2D representation of this crystal structure.
So could you rotate the 3D for this?
I am not able to.
Okay, so I've opened it.
Then share your screen. No?
So like, what do I do?
Share your screen.
Yeah.
So it's showing that plain thing only. I also searched.
Maybe you just stop sharing for me to share the screen.
Yeah, right. Okay. So no, so it's coming the same. It's the same plane structure and I type the spelling correctly. Buckyballs are supposed to be balls.
The number of atoms are at 60 only.
It is a planar molecule.
Buckminster Fuller.
Yes.
Oh, so why are they called buckyballs?
Because it is similar to the outside of the football.
Oh, okay, right.
I just saw it is planar. Lie in the same plane. Wow. Okay, are you able to see my screen?
So it's sphere shaped.
What?
So no, like I Googled this and it's coming
I-
sphere shaped.
I also googled it. Like it is showing it's planar.
So can I send I'll copy paste it and send it in the Zoom chat.
Yeah. Okay, okay, okay. Yes. It is non-planar. What are they trying to? I have shared one image. Are you able to see that?
Yes, so sort of what image?
Yeah, that should be. But why are they not showing it here?
So it's saying it's a Fullerene molecule. Fullerene molecules are basically like cage-like fused ring structures. That's sort of what we're getting, right? Wait, I'll send it. That's written for C70, not C60, but it should be the same.
Yeah, this is not correct. I mean, it's not planar.
So it's confusing the structure of C60 with C70. I sent something in the Zoom chat.
You have sent something.
The last thing I sent, I think they're confusing C60 with C70.
Soccer ball, okay.
So
Okay,
the
okay.
last message.
Yeah.
It's a cage-like fused ring structure.
Yeah, it is non-planar. It is non-planar. Okay.
Yeah.
So in the last class, I talked about, if you remember, I talked that methane. I said that methane is non-planar. So by non-planar, I meant this. Okay. Is everyone able to see and understand why it is not planar? Sit properly. Telling it to you. Sit straight. Don't sleep.
Okay.
See, is everyone able to see? Guys,
Yes, sir.
Yes, sir.
are you able to see methane? So this is not planar. Okay, this is what I wanted to say. Okay. So then we were talking about diamond. Then we are talking about graphite. Okay. Okay. So in graphite, what happened in graphite? So I told you there are layered structure, hexagonal. In the plane, you will have hexagonal layers. In particular, this is one plane. This is one plane, and below you have another plane. You will have another plane. Okay. Hexagonal planes honge, and these planes are connected by weak van der Waals forces. Van der Waals forces.
So what is this Van der Waals force?
I mean, this is the name of a type of force which is very weak, and this is a type of force which doesn't involve any type of contact.
So can you explain by like what you mean by it doesn't involve any contact? Contact, right? But so if both layers are not in contact with each other, won't graphite come as this kind of comb structure with a lot of different layers, seeing as how they're not in contact with each other?
Yeah, I mean, they come like that, but this distance is very less. This is in picometers.
So picometers, how much?
10⁻⁻12.
Oh, okay, right.
And when I say van der Waals forces, so it is okay. I will explain you what are van der Waals forces. ध्यान से सुनना. Did I record it?
Yes, so you are. You're recording.
Okay. Okay. So when I talk about van der Waals forces, everyone concentrate. Van der Waals forces क्या होता है? जैसे मान लो कि let's say I have two atoms. Let's say कि I have two atoms. मान लो helium का ही मान लो, ठीक है? Let's say I have two different helium atoms. So helium के पास how many electrons you will have? Let's say this is the nucleus. Let's say this is the nucleus. So how many so let's say this is helium A. Let's say this is helium B. How many electrons you will have in helium, and how many protons? Okay. So let's say that for a period of time, the electrons, let's say the electrons are mostly situated in this region for a instant of time. Okay. And let's say that in another helium atom, the electrons are in this particular here. Majority of them are here. Let's say
There
that.
are like two.
Huh?
There are two helium atoms.
Yeah, there are two helium atoms, and let's say few of them are concentrated in this area for some time, and few of them are concentrated in this area, obviously in different atoms. So are you able to see this nucleus is getting attracted to these electrons for a fraction of a second?
Yeah.
So this is what is known as a van der Waals force, very weak force, right, which happens instantaneously. This is an example of a van der Waals force. Weak.
So then anything that's held together by van der Waals forces, how does it stay together?
Was it
How does it-
continuous, I guess?
I mean, it happens instantaneously. Hota rehta hai.
No, so but if it's happening instantaneously, that means it must be going on and off every second.
Yeah.
Right.
Yeah.
So then how is the material staying together for like
Because
prolonged periods of time?
I mean, that's why it is weak. That's why graphite is very weak. Are you
Right.
getting?
Yeah.
That's why it is used as a lubricant, because these van der Waals forces are not strong enough to hold these two particular layers. That's why you can easily break it. Weak forces.
Right.
Okay. So I hope you understood the difference between graphite and diamond, the structure. Okay. And one more important difference I want you to see is, if you see here, this is a structure of diamond. Okay. If you see this particular atom, let's say any particular atom, this is linked to 4 others, 1, 2, 3, 4, and carbon is tetravalent. You know that, right? So all the valency of carbon is satisfied in diamond. So no atom or no electron is free. That's why you cannot have conduction. All the electrons are involved in bonding. But in diamond, if you see any one atom, this is linked to 3 other. One is free. So that electron is responsible for conductivity. Understood, everyone?
Yes, sir.
So how you, I mean, if someone asks you why is diamond non-conductor, but graphite is a conductor, so you have to show the structure and you have to show that one valency is free in graphite, one valency is not free in diamond. I mean, nothing is free in diamond. That's why diamond is non-conductor, graphite is conductor.
also when there's like free valency, electricity can pass through it.
Yeah, the electrons can pass, right? What is electricity? The flow of electrons,
A
right?
flow of electrons.
So that means when you pass electricity through graphite, it must be easier to break.
What will be easier to break?
Graphite. You pass electricity through graphite. By that logic, it would be easier to break.
Yeah, it is easier to break.
When you pass electricity through it, really.
When you pass electricity, I mean, what is the relation between electricity and hardness? Hardness is a physical property. I mean, yeah, conductivity is also a physical property. Okay.
So, no, so you're saying that the physical property is directly related to the fact that graphite involves free valence electrons that attract the nuclei of the opposite layer.
Yeah, for a momentary seconds, few momentary
For
seconds.
momentary seconds,
Yeah.
right? And then when you pass electricity through it, those electrons start moving.
Yes.
So even that instantaneous bond is not going to happen in a lot of cases.
There are these electrons which are remaining.
So
What
it
about-
will happen, but not all of it is going to happen.
Yeah, so see, it does not make it. See, these are, I mean, you cannot pick something and then say that it is responsible for that. Are you getting? The strength is a totally different thing. The strength is dependent on the kind of forces, the kind of intermolecular forces.
So what I'm saying is this: when you pass electricity through graphite, electrons are going to start moving from the valence electrons will start moving from their positions.
Okay.
Then those electrons, the gaps that those electrons left, now not all of the electrons are going to go with the flow, but some will. So
Okay.
clearly the bonds are going to become, if only a fraction, they will become weaker. Slightly.
Okay. Fine.
And that means graphite itself becomes weaker.
Fine. Yeah. Yeah, you can say the strength has decreased by a bit. Yeah, that you can say.
That means when you pass electricity through graphite, it must be easier to break.
Yeah, but it is, what I'm trying to say is it is easier in the molecular scale, not in the macroscopic scale.
Right. Okay.
Okay. Then let's talk about the uses of diamond. Okay. So write down some of the uses of diamond, everyone. The first one is it is used in cutting instruments like glass cutters.
Sir, I have a doubt.
Abhi nahi, ruko. Everyone write down the uses of diamond. Open Eschan. Open Eschan, everyone. Write down the 3 uses of diamond that has been given in Eschan. हाँ जीवितेश बोलो.
Sir, you told that graphite is the good conductor of electricity. Sorry,
हाँ.
it can allow the electrons to pass through. Sir, but it is a non-metal which will not conduct electricity. So doesn't it contradict the statement?
तो exceptions नाम का चीज होता है ना.
Okay, sir.
Iodine is a non-metal which is lustrous.
Oh, yes, sir.
तो exception नाम का चीज होता है, right? That's why I'm saying कि properties depend on the arrangement.
So instead of writing the entire thing, can we write diamonds are used in cutting instruments?
Yes, use your brain, everyone. Read the points and write them. Write them briefly. One you can write down, they are used to make instruments like glass cutters, etc. They are used to make jewelry. Then third one you can write, they are used by surgeons to remove cataract from eyes. Do you know what is cataract?
So like your cornea, right, or your lens, something becomes milky and opaque and light can't pass through.
Yeah, so that particular thing is removed from your eyes. So write
Sir,
down those. हाँ बोलो.
Can you repeat the cataract point?
उसी में एस्चन नहीं है क्या तुम्हारे पास?
Sir, है, I was reading it.
वो sharp edge diamonds are used by eye surgeons to remove cataract from eyes. When you complete this, next you write down uses of diamonds. Uses of graphite. Okay, like I want to say something. If you have some doubts which is related to what we are doing currently, I did not say the chapter. I'm saying if you have any doubt which is related to what we are doing currently, then you can ask that. If you have some doubts which is not related or which belongs to some other part of the lesson, you stay back after the class and ask. Is it clear, everyone?
So but doubts that come while you're teaching a particular topic in that topic, we can ask.
Yeah.
Right.
in that class. Yes. Anything apart from that, or manlo some other topic, then write that down somewhere and stay back after the class, not in the class, because it is consuming some time. In graphite, you can write it is used as a lubricant. Second, you can write, since it is a good conductor of electricity, it is used for making electrodes. Third, you can write it is used to make the cores of our pencil called pencil leads. Those things you can write. Are you done writing everything?
They are only in small class.
When you are done, let me know.
Sir, done.
ठीक है. अरे हृदय भी है क्या?
Yes, sir.
I did not see you.
Slow down. So, small question about that thing you said about the macroscopic scale.
एक second. मीटिंग आईडी क्या है? 783286. एक सेकंड. हाँ, एक सेकंड. 783286. 7832865050. ठीक है. हाँ.
So, the macroscopic scale thingy.
One second. हाँ, tell me.
So, you were saying that the explanation for electricity being passed through graphite is not going to work on a macroscopic scale.
Yeah.
Why? How? What? Macroscopic scale, why? Like what? How? Why? So I mean, like anything you do on the molecular level is going to affect the macroscopic scale, right?
See, the reason is because the reason is I have a question. If carbon, देखिए ध्यान से सुनना शिवांश, अगर carbon, if it is linked to 3 other bonds, if it is not linked to one another bond, then how is it stable? How is it forming graphite? That is my question. Where is the other electron? Then it is not carbon, right?
No, but it's arranged in such a structure.
Yeah, where is the other electron?
No, so for that you have to arrange it in a hexagon.
Exactly. No, if you even if you arrange in a hexagon, where is the other electron?
So that means like multiple. Oh, that means graphite is partially unstable.
It is not. It is not. That's why I am not saying some of the things which is not there in your syllabus. Okay.
Okay.
So I should tell you many things. For example, that graphite का structure ये होता ही नहीं है. ठीक है? Actually speaking, graphite का ये structure होता ही नहीं है because carbon का 4 valency satisfy होना चाहिए. और एक valency कहाँ है?
So the chain is just going to keep going, and it won't end.
So where is the other electron? Where is the other bond?
So it needs some other element to attach to it.
No. So that's why there are double bonds. Actually, there are double bonds. It is actually consisting of benzene rings. समझ में आ रहा है?
Benzene rings are double bond rings.
Yeah. So actual ये होता है, लेकिन मैं कुछ चीज नहीं बोल रहा हूँ क्योंकि वो एग्जाम में मत लिखना. ठीक है?
Right. Okay.
Fine. So did you write the uses of diamond? Did you write the uses of graphite?
Yes, sir. Okay.
Fine. So next, let's talk about Buckminster Fullerene. So everyone see Ashton, they have drawn figure 10. Is it figure 10 in your textbook also?
Yes, sir.
Okay, so see that structure, draw that structure, everyone. I mean, एक rough diagram बना लो.
So one carbon atom is connected to the 3.
Here also, see.
Sometimes like 5.
Here also one carbon is attached to how many?
So, but like over here is also attached to 5. But
How is it possible?
I have no idea. So it is.
It's attached to 3, right? How is it attached to 5?
Oh wait, that's behind. Okay.
Yeah, it's behind.
Yeah. So then it has double bonds, right?
It has double bonds, but it is not mentioned in your textbooks. Nowhere.
Okay.
So Buckminster Fullerene, if after you have drawn a rough diagram, just write down that it's an allotrope of carbon, which consists of 60 carbon atoms joined
So
together.
could you show how to make it?
Figure 10 में है ना, उसको बना लो ना यार.
Okay, sir.
Just make some hexagons in a football shape. Hexagons भी है, pentagons भी है. Have you noticed? There are pentagons also.
Yeah. Yes, sir.
Yeah, it consists of hexagons and pentagons both.
So small question though. You can arrange graphite in such a way that you know, like carbon doesn't need to fulfill the other valence electron. You can do arrange it in such a way, right?
Oh,
Simple. Just loop the layer around. So like the electrons on one layer connect to the electrons on the other layer, which is what you want. You can loop the hexagon layer.
loop in the sense I'm not getting.
No, like, so like you have the hexagon layer, and the main issue with the model of graphite is the valence electrons. There are some valence electrons which are just not like combined, right? Like there are some valence electrons which are still left. And so by that structure, graphite is meant to be unstable, theoretically. So, but then wouldn't it be logical to just create a sphere of hexagons?
It does not exist as sphere. That's what I'm saying.
No, so like, but why not?
Because it does not. Why is, for example, why is methane not planar?
So because it can't exist otherwise.
The same thing here. Even if two things can exist, the one which has less energy will exist.
Will exist.
It will exist. The one which has lesser energy.
Right. Okay.
Okay, so everyone write down Buckminster fullerene is an allotrope of carbon containing 60 carbon atoms joined together to form spherical molecules. It's spherical in shape. And it has 20 hexagons and 12 pentagons.
So Buckminster fullerene is an allotrope of carbon.
So like you can ask me why only 20 hexagons?
So I was
Why?
going to ask that just now.
Huh?
I was going to ask that just now.
Yeah, so some of them are facts, man. I really cannot answer. Some of them are plain facts.
Sir, so then why you said you can ask me?
Huh?
Sir, you said you can ask me, so
I talked about asking. I did not say whether I will be able to answer it or not.
So like my question wasn't like, why
No,
is it?
one second. I need to talk to Garvit. Yeah, what is the issue?
sir, no issue. I was just saying it.
Yeah, what you are saying, can you repeat?
So I was saying that you said you can ask me this. So yeah.
When did I say that?
So you just said like it has 20 hexagons and 12 pentagons, so you can ask me why it has that.
अरे भाई, that was a statement. मैं बोल रहा था कि ये भी तुम लोग मेरे को पूछोगे करके. I was trying to say that.
Oh, okay. Like
तो
sarcasm kind of.
इसका मैं क्या explanation दूं? मुझे खुद बताओ कि 20 हेक्सागन है, 12 पेंटागन है. ये जैसे ताजमहल आगरा में है, क्यों है वहां पे? है ना?
So because Shah Jahan happened to be living.
हाँ, तो इसीलिए.
And then if you asked me why Shah Jahan was living in Agra, I'd give you the history.
It was created there, right?
Yeah.
Yeah. So that similarly, whoever made C60, it created 20 hexagons and 12 pentagons. Okay? Abhi Sivansh, what is your question?
No, so my question is not that. It is it not possible to create a sphere of only hexagons? Hexagons of carbon. Is it not possible? Because that solves all of graphite's problems.
Yeah, like if it was possible, then we would be having that, right? But we don't have.
So it's not possible.
Yeah, that's why we have graphite, we have, I mean, we have hexagons, but we don't have spherical hexagons, everything hexagon. Right?
You don't have a sphere of hexagons, right?
Sphere of hexagons. Yeah, we don't have that. We have a combination of hexagon and pentagon.
Yes, sir.
So it has, I mean, so graphite or diamond में क्या होता है? It consists of a huge number of carbon atoms, but here the carbon atoms are limited. It's just C60. Okay, that's the difference. It's just 60 molecules of carbon. Okay, and next, I mean, it has similar chemical properties because these are allotropes, right? Allotropes will have different physical properties. How different? For example, diamond is very hard, graphite is very soft, but Buckminster fullerene is in between, neither very hard, neither very soft. And like, how is the chemical property similar? If you burn diamond, are you writing or not?
Here I am.
Are you writing or not?
Thanks.
So what do you mean by neither soft nor hard?
In between.
Like, would it be easy to bend?
In between. It's not neither very hard nor very soft.
So would the same thing be true for every property?
Huh?
Like, for example, diamond doesn't conduct electricity. Graphite is a good conductor of electricity. So maybe Buckminster fullerene would partially conduct electricity.
No, it won't.
Okay, right.
And it's a new guy. I mean, it's new in the market. So many things are being, people are researching, still doing research on this. Okay, and like for example, it has similar chemical properties. Kaise? Jaise, if you burn diamond in air, you're going to get carbon dioxide. If you burn graphite in air, you're going to get carbon dioxide. And if you're going to burn Buckminster fullerene, you're going to get carbon dioxide. Okay?
So in this it's written, if we burn Buckminster fullerene and oxygen, then only carbon dioxide is formed and nothing is left behind.
Yes.
So you would agree that coal is pure carbon,
Okay.
like at least in theory. So when you burn coal, why do you get ashes?
Ashes are also carbon, right?
No, sir, but when you burn,
Which are, wait, one second, which have not completely burned.
so if you burn the ashes further, will you get carbon dioxide?
Yes,
And you could keep burning it until all the ashes went.
it will fly away.
The carbon dioxide.
The carbon which is left behind will burn away, it will fly away. It will form carbon dioxide and go into the air, atmosphere.
Right. Okay.
Okay, next let's talk about organic chemistry. We're going to talk about a separate branch of chem, that is organic chemistry. So it involves the study of carbon and its compounds. Okay, it involves the study of carbon and its compounds. see in the screen, Dhruvi. So it involves carbon and its compounds. Okay. So and there are more than 5 million organic compounds. More than 5 million. That's a huge number. Okay. So there are two reasons why we have this much organic compounds. First reason is catenation. Second reason is tetravalency. Catenation of carbon and tetravalency of carbon, these are the two reasons. Catenation मतलब होता है self linkage. Okay, self linkage मतलब, for example, you will never see bonds like Na ऐसे linked to themselves, but you will see bonds like carbon which are linking to each other. Okay, this is a special property of carbon. If you remember, I told you this in the last class.
So silicon also shows this property.
Silicon also shows, but
Sir,
not to an
but
extent.
due to
एक second, मेरे को बोलने दो पहले. And if you want to say something, don't say in the middle. It irritates me. Okay. So if you have carbon, so silicon में क्या होता है? Maximum 6 or 7 atoms, but carbon में you can have even like I have seen 70, 80, 90. That much also can happen. Okay. So if you have some doubts, you can raise your hand. There is a feature in Zoom, I think. Garvit, bolo.
I was saying about silicon earlier.
Okay, so silicon also does that, but not to an extent of carbon. Okay, and it also belongs to the carbon family only. Okay, so that's the first reason. The first reason is catenation. Why carbon only? Because there are 4 electrons and also the size is small. So whatever bonds are being formed between 2 carbons, the electrons, since the size of carbon is small, the electrons involved in the bond will be attracted more to the electron, and hence a strong bond will be made. Okay?
So could you repeat your sense?
So I said that why carbon shows catenation? That's because carbon is small in size. Okay? Since it is small in size, जो भी shared pair of electron है, or you can say the electrons which are involved in bonding between 2 carbon, since these will be nearer to the carbon because carbon is smaller in size, so that's why जो attraction होगा nucleus के protons and electrons के बीच, that will be strong. So that's why the molecule जो भी compound resultant compound है, that will be very stable. So that's why बड़े chains you will be able to see, huge chains you will be able to see. That's one of the reasons. Okay, and the next reason is tetravalency of carbon. Tetravalency of carbon. So it is, I think it is understood that since it has 4 valency, so it can afford to link with other guys. Let's say it was monovalent, difficult, थोड़ा difficult होगा है ना? It is tetravalent means 4 valency मिल रहा है, 4 opportunity है bond बनाने का. So these are the 2 reasons that you should write down.
So small question. Can it, like, clearly monovalent monovalent compounds can't form catenation.
Cannot show catenation.
Yeah, they can't show catenation. Neither can divalent compounds, because if they show catenation, then the arrangement would be unstable, right? If you think about it. Because some part of them would always remain unbonded. So that means every compound has to be every element has to be at least trivalent to show catenation.
Catenation is shown only by carbon and silicon.
So that's my question. Like, if the minimum limit is being trivalent, why isn't everything above trivalency A like capable of showing catenation? What is so special about carbon?
There are many factors involved. That's I told you tetravalency, I told you small size.
Yeah,
Okay.
yeah. Small size keeps the electrons closer to the nucleus.
Yeah.
So, but like, shouldn't that be true for other atoms as well? Like, take phosphate. Like, phosphate is a radical and its valency is 3.
Okay. It also depends on the element to form covalent bond also.
How could you explain?
I mean, you are saying that, let's say some guy has it's trivalent, and why it is not showing catenation? To show catenation, it should form covalent bonds. What if it is ionic?
Yeah.
You can lose 3 electrons to become ionic. So what if it
Yeah.
prefers the ionic route instead of the covalent route?
So it has to be exactly 4.
Yes. So that it forms covalent bond.
Okay. So, by the way, what's the atomic number of silicon?
14.
Okay. So then 284. So 4 in its outermost shell.
Yes, it's in the same family of carbon.
That's why it doesn't show that much catenation, because the shell
Size
carrying
increases.
4 electrons is farther away.
It's the size is greater.
Yeah. Okay.
Okay,
Sir?
so हाँ.
एक डाउट है, आपने बोला कि आपने 78 तक देखा है कार्बन में, तो एक इन्फिनिट चेन नहीं बन सकती कार्बन की फिर?
तो वही तो मैं बोल रहा हूँ, डेली डिस्कवर होता है. अभी
Okay.
5 मिलियन में एक रफ एस्टिमेट बोला मैंने, ठीक है. सो दे डिस्कवर इट, क्या पता उससे भी बड़ा मिल गया हो.
Okay, sir.
My aim is to tell you that कि there is many compounds possible. There are many compounds possible, many organic compounds, and daily they discover something. अब नेचर में होना भी चाहिए ना. Theoretically तो infinite हो सकता है, वैसा मिलना भी चाहिए ना.
हाँ sir, okay.
Okay, who has raised their hand? अच्छा, हृदय ही था क्या? Okay. ठीक है. So now we are going to talk about hydrocarbons. ठीक है. Now we are going to talk about hydrocarbons. ठीक है. तो hydrocarbons मतलब क्या होता है? Organic compounds which consist of. Okay, like before that I want to say something. Organic compounds, ठीक है. Okay, so देखो, organic compounds have low boiling and melting point compared to ionic compounds. Do you know that? Because the bonds in ionic compounds are stronger than the covalent compounds. ठीक है? Write this point down. That's why most of the organic compounds are either gases or liquid, and most of the ionic compounds are solid. Have you observed?
So wait, cellulose is an organic compound and it's solid.
Obviously, there are some exceptions.
So that means like
I
skin.
said most of them.
Okay, right. So can you repeat the point? Entire point.
So my point is, organic compounds, or you can say compounds which involve covalent bonds, have low melting and boiling points. And also covalent compounds they don't conduct electricity because they don't dissociate into ions. अब there is one like एक incident था कि earlier people used to think that organic जो organic compounds होते हैं they can be extracted only from living organisms. Are you getting what I'm trying to say?
Yes, so exotic chemicals.
People used to think that you get organic compounds only from living beings. For example, animals, humans, or all the living things. But so people used to think that if you want to create organic compound, you cannot do that yourself. You cannot take synthetic things. Okay, so but which was proved wrong. Okay, because one guy made urea in the lab using inorganic compounds. समझ में आ रहा है? Urea is an organic compound. Do you know that? Okay.
Yes,
So it's a inorganic urea is an organic compound, but one guy, his name was Wohler, he made urea using inorganic compound. So this theory is abolished, right? This is wrong, no?
how did he do it?
He took ammonium cyanide. And then he heated it.
So what's the formula for cyanide?
NH4CNO, ammonium cyanide. He made it from that.
So CNO's valency is 1.
Yes, -1.
-1.
NH4CNO. When you heat this, it became urea. NH2CO NH2. देखो दोनों का फॉर्मूला सेम है.
So wait,
Okay.
if you heat it, won't it combine with oxygen?
Limited supply of air.
Okay, and so how will it rearrange itself? Won't it decompose?
It becomes something else.
Yeah, so it's only
That's not important to us for now. That's not important to us.
okay.
What is important to us is he made a organic compound urea using a inorganic compound ammonium cyanide. That is what is important to us.
Okay, right.
And if you want to know how this happens, we can discuss it after the class.
Right. Okay.
Okay. So next is different type. Okay. So I will show you different kinds of organic compounds. For example, you can see these type of compounds. जैसे ये है. So this is a straight chain compound, organic compound, straight chain. You can also see branch chain. So these are forming a branch. You can also see closed chain, जैसे carbon. This is a closed chain. This is a straight chain. This is a branch chain. This is a closed chain. In what forms you can find carbon atoms? How are they linked? Ishan, why is your video off?
1 second, sir. I have to fix the camera. 1 minute, I'll just bring it back.
Okay, so then you write down, let's talk about hydrocarbons.
So straight chain, closed chain, and
Branch chain.
branch chain.
BRANCHED. Straight, branched, and closed. Next, we have hydrocarbons. So write down the definition of hydrocarbons. Organic compounds which consist of only carbon and hydrogen. Organic compounds which consist of only carbon and hydrogen. Example, write down methane. methane, ethane, ethene, propene, ethyne, propine. These are some of the examples. ठीक है? बाद में देखेंगे. Their formula we'll see later. So what is common in them is these are all made up of carbon and hydrogen. ठीक है, एक दो का फॉर्मूला देख लो. मीथेन इज CH4, प्रोपीन इज C डबल बॉन्ड C, C3H6, yes, C3H6. Propine is C triple bond C, so it is CH 3 4 3 1 3, हाँ, C3H4. ठीक है. I will tell you how to, I mean, याद नहीं रखना है. It's very simple. Just write down these examples.
So the propine formula isn't visible very clearly.
ठीक है. C triple bond C H. See guys, one more thing I want to say is I am going to draw एक बार सब लोग इधर देखो. See in the screen, everyone. I am going to draw organic compounds like this. ठीक है. Hydrogen. Don't think that there is no hydrogen here. Hydrogen वहां पे है. You have to think automatically that hydrogen is being satisfied. अब देखो, carbon is tetravalent, right? So here only 3 valency is satisfied. That means auric valency, who is satisfying that?
One H.
So there is one H. It is understood. I am not going to draw it repeatedly. Okay, so propine का structure is this. So जहां पर you see tetravalency is not satisfied, वहां पे hydrogen डाल देना, because in hydrocarbons you have carbon and hydrogen. Okay.
So in the very second carbon,
हाँ.
in the very second carbon, like the triple bond is facing this side and single bond is facing that side. So there'll be no H there.
Yeah, no H.
But in the first carbon, in carbon number 1, it'll be CH3, right?
Yeah.
Okay, right, okay. So wait, is this why you write acetate as CH3CO?
Acetate.
Yeah, is like
no. Acetate is an ion. Acetate is CH3COO minus.
okay,
It's
so
acetate, it's acetate ion. Acetic acid is different.
so yeah, so like this is why you write acetic acid not as C2H4O something. You write it like this because it's formed this way. It's bonded.
No. See, you can write this like this also. C2H4O2. है ना? यही बोल रहे हो ना?
Yeah.
You can write it like this also. लेकिन देखो, acetic acid में I want to show the functional group. That's why I write it like this. CH3 and the functional group is COOH. Functional group मतलब होता है कि acetic acid को who is responsible for the properties that is shown by acetic acid? This COOH group.
Correct.
That's why I want to show this COH. That's why I write it CH3COH.
So that's what I'm saying. This is why you write it CH3COH.
To show that it has a COH functional group.
It's because it's formed this way.
अबे formed on क्या भाई? Like it's a molecule.
It looks this way, sort of.
No, the molecule looks the way that I will show you in mole view. It will look like that.
So I mean, like you get what I'm saying, right? Like.
Wait. Yeah, that's a representation, man.
It's represented that. My bad. That's
representation.
Yeah. Okay.
So CH3COH is like this. So these red color atoms are oxygen. Are you able to see?
Yeah.
So are you able to see a gray color, 2 gray color atoms?
Yeah, those are carbon.
Those are carbon, and the white color atoms are
hydrogen.
Okay. So to one carbon, there is a double bond O, and there is to the same carbon, there is a single bond O, and that single bond O, there is a hydrogen attached there. Are you able to see?
Yes, sir.
And are you able to see that the double bond O and the OH are in the same plane? Are you able to see that?
Yes, sir.
You are mute, Shivansh.
So CH3 is non-planar.
CH3 is not planar, but the C double bond O, COH is, both these groups are in the same plane.
Yeah.
Okay, that's what I want you to observe. ठीक है, बस observe करो.
So does that have anything to do with its like properties?
No, it has something to do with something which is not there in your syllabus.
So everything is out of our syllabus.
Huh?
Everything is out of our syllabus.
I don't think so. How is everything out of your syllabus?
I mean, everything fun is out of the syllabus.
Huh?
Everything interesting is out of the syllabus.
That's because there is a reason for that. Because if I tell you the reason, to understand that, you have to gather some knowledge, which takes time.
Right. Okay.
For example, you learned about covalent bond now. If you want to learn about why exactly carbon is why exactly methane is tetrahedral, or why do molecules have shape? So you will learn this in 11th standard the next year. There is I can tell you, but if you can stay back if you want to know. It will take some time.
I can't stay back today. Oh.
Huh?
So I have a Hindi test. So I can't stay back.
You are not audible.
So I can't stay back today.
Fine, that's okay. Okay. What was I talking about? Okay. So yeah. So these are some of the examples. Okay. So for hydrocarbons, write down the sources of hydrocarbon. Where can you find them? The sources of hydrocarbon. So they are found in petroleum. So petrol consists of hydrocarbons. Remember that. Petrol consists of hydrocarbons.
So like only petrol or including petrol and diesel or any other petroleum products also?
Example में I said petrol. Petrol में मिलता है. Did I say that only petrol में मिलता है?
No.
Yeah, it is also found in diesel. It is also found in other petroleum products.
Sir, in that PDF you sent of Chan, you have done only till organic compound, the last page.
आगे बोलो.
So next page is there, or is it like the end of the chapter?
नहीं. I will be mostly dictating, so no need of that.
Okay.
Next, write down types of hydrocarbons. Everyone, types of hydrocarbons. Types of hydrocarbons. So you have saturated and unsaturated. First is saturated. Second is unsaturated. Saturated hydrocarbons are also known as alkenes.
So the spelling is ALKANES.
Saturated hydrocarbons are also known as alkenes, and unsaturated hydrocarbons में दो टाइप होता है. Alkenes types, ठीक है? Two types, alkenes and alkynes. alkenes and alkynes. ठीक है. Next, write down saturated hydrocarbons. Let's talk about saturated hydrocarbons. Okay, write down the definition: a hydrocarbon in which the carbon atoms a hydrocarbon in which the carbon atoms a hydrocarbon in which the carbon atoms are connected by only single bonds. Only बोला मैंने, ठीक है? तो डबल और ट्रिपल मत डाल देना इसमें. Only single bonds. Okay. Now something about bonding. So, do you guys know about covalent bonds?
Yes, sir.
I am asking something and you won't reply.
Yes, sir.
Yes, sir.
हाँ. तो उससे गुस्सा दिलाओगे तुम लोग. So covalent bonds are formed by sharing. I mean sharing होता है. The orbitals are overlap. The orbits overlap. ठीक है? Orbit and orbitals are different things. लेकिन अभी के लिए ठीक है. चलो orbits overlap होते हैं. ठीक है? So this is the shared region. जहाँ पे this is the shared orbit. So where the shared electrons are going to spend most of the time. So if two electrons are shared between them, then it is, what kind of bond is formed? कोई answer नहीं. Single. I told. I'm not talking about you. Talking about the online guys. So it forms a single bond, and when you share 4 electrons between them.
So it will be double
Double.
bond.
Double bond. और जब 3 electrons होता है,
Then triple bond.
Triple bond.
ठीक है, बना लो.
So this should be under saturated one, right?
No, this is a different thing. लेकिन हाँ, saturated के नीचे ही बनाओ. In single bond 2 electrons, or you can say a pair of electrons is shared. Double bond में 4 electrons या 2 pairs of electrons are shared. Triple bond में 6 electrons or 6 or 3 pairs of electrons are shared.
So can you go a little up? Sir, for the single bond, is it necessary that we have to draw the electrons vertically, or is it possible horizontal also?
Friends, कैसे ही बनाओ यार. ये कैसा क्वेश्चन है जीवितेश?
Am I audible? Am I audible?
Yes, you are. You want to ask something?
No, sir, I was answering.
What are you answering?
The single bond, double bond thingy.
No, I did not. I think you are mute.
Oh, okay.
ठीक है, तो alkanes में क्या होगा? They will just have single bonds. ठीक है? So write down examples: methane, ethane, propane, butane, pentane, hexane, ethane, nonane, octane, nonane, decane, dodecane, etc. etc.
So these examples are for which bond?
These examples are for alkanes or saturated hydrocarbons.
So ane is the suffix for saturated hydrocarbon.
Yes, for alkanes. Alkane mein it ends with ane, right?
Yeah.
So the structure of, now we'll talk about the structure. एक बार example लिख लो सब लोग. Okay, so we'll talk about the structure of methane. In paper, I'm representing it like this. This is methane. Ethane is C double bond C. Hydrogen अपने से बना लेना. Are you able to understand what I'm saying? These carbon atoms
Yes.
का valency satisfy कर देना. So this is ethane. Propane is, butane is. ऐसे बढ़ते चले जाते हैं, ठीक है?
So methane is starting 2 and then it grows.
Repeat.
So it's like methane has 2 atoms of carbon, then it slowly increases.
Methane has 1.
Okay.
Methane has 1 carbon atom. Ethane has 2 carbon atom. Propane has 3 carbon atom. एक एक करके बढ़ते चले जाते हैं.
Okay, sir.
ठीक है, ब्यूटेन तक बना लो. ब्यूटेन तक बनाने के बाद मेरे को फॉर्मूला बोलना उनका. मीथेन का फॉर्मूला है CH4. I will ask you. Okay, I will ask Ishan. Tell me the formula of ethane.
Sir, ethane.
हाँ.
C2H6.
That's 6. Is it correct?
Correct. Yes, no.
Okay, ठीक है. जीवितेश, tell me propane का फॉर्मूला बताओ.
So propane will be, okay, 1 second, sir.
Final one is butane.
Yes.
So okay. So it will be C3 and sir C3 and H7.
H7 गलत है.
So can I tell?
हाँ बोलो.
So C3 and H8.
ठीक है.
So H7 is propan, right?
Yes, when you remove the hydrogen atom. ठीक है. ब्यूटेन का बताओ. हृदय बताओ.
So C4H10.
Yeah. It's correct. C4H10. ठीक है. So everyone write down the general formula of alkanes. General formula of alkanes. General formula of alkanes is CnH2n+2. ठीक है. तो जैसे मान लो कोई पूछ रहा है पेंटेन का फॉर्मूला बताना, तो n का वैल्यू क्या डालने वाले हो तुम?
Sir 5.
Put n का वैल्यू as 5, you will get 12 ना. So the formula of pentane is C5H12.
So for then butane it will be 4.
हाँ.
Okay.
So, like, one last question. Why is butane not called quadrane? I mean, quadro means 4.
I cannot answer. This is nomenclature.
Okay, right.
There are some rules which are set by IUPAC. where whenever you have one carbon atom, you have to use the word meth. Whenever you have two carbon atoms, you have to use the word eth. Whenever you have three carbon atoms, you have to use prop. So what was your question? Your question was why, I mean, can you repeat your question, Shivan?
So why isn't it called quadrane? That was my question. I got my answer. It's just nomenclature.
Yeah, it's just nomenclature.
I mean, there's nothing you can really do about it.
Yeah. I hope you are understanding my situation.
Sir, I'm so sorry.
That's okay. But really, some of these doubts are like, it really makes me angry because I don't have an answer. For example, जैसे वही सब ठीक है, but okay, ठीक है. And write down one more thing. अभी जैसे I gave you examples of hydrocarbons, right? So hydrocarbons में you have alkenes, and you have alkynes, right? तो तीन क्लास है ना hydrocarbons में. तो एक चीज मैं I want to say one thing. That thing is, out of these three classes, this guy alkenes, these are very unreactive. Okay, remember one thing, these are unreactive compared to alkenes and alkynes. These are unreactive. Comparison में बोल रहा हूं, that doesn't mean they are not reactive. Otherwise oxygen के साथ क्यों react करेंगे? And I will tell you the reason. थोड़ा wait करना.
Because alkenes don't have any other bonds. Is it related? Like because alkenes they have like one double bond. So that double bond can be removed from the carbon and can be added to something else.
But aren't double bonds harder to break?
Yeah.
Yeah, but like it's wrong.
Yeah. Yes. So that means alkene should be less reactive, right? Oh, sorry. Yeah, it should be less reactive, no?
Yeah, double bonds are harder to break.
And alkyne should be the least reactive.
Yeah.
But the order is actually alkanes are the least stable.
How?
Yeah. So I will tell you that when I finish discussing alkenes and alkynes, okay? So then you write down unsaturated hydrocarbons. Unsaturated hydrocarbons. So unsaturated hydrocarbons में क्या होता है? So obviously there can be single bonds, but okay, ठीक है. Before telling you, before going there, let's say unsaturated में दो types है, तो let's choose any one type, that is, let's say alkenes. Other type is alkynes, ठीक है? So alkenes क्या होगा कि they will have minimum necessity, minimum requirement is कि एक double bond होना चाहिए. There should not be triple bond. Single bond हो सकता है. Are you getting what I'm saying? Let's say if there is a double bond between two carbon atoms, that means it's an alkene. But let's say you also have double bonds, but also you have single bonds, then also it's an alkene. Lekin, if you have C triple bond C, but you have double bond in the other carbon, then it's not an alkene, it's an alkyne. Are you getting? How is the how is the priority assigned? The triple bond gets more priority over double bond than the single bond. Understood? So if a molecule has all three, जैसे मान लो triple bond भी है, double bond भी है, single bond भी है, then it will be an alkene, alkane, alkyne. क्या होगा?
Alkyne, right?
Alkyne. बाकी सब लोग क्या सो रहे हो क्या? रिप्लाई कहाँ है क्वेश्चन का?
Just given.
No, not you, man. Garbit, Jivitesh, Ishan, Hiday. What will be the answer?
Sir, alkyne.
ठीक है? So alkene मतलब क्या होता है? If you have just C double bond C, fine. But if you have double bond, yeah, single bond भी है, then also it's an alkene. ठीक है? For example, write down. So can we have methane?
The methane.
No, you can't. No.
So
So
no.
methane is
First, because it sounds weird, and second, because it's not possible.
Yeah.
okay.
I don't want you to write the first reason.
Sir, it's single bonded, I guess. That's why.
देखो डबल बॉन्ड बनाने के लिए 2 कार्बन तो चाहिए ना भाई, तो
Yes, sir.
नॉट पॉसिबल. ठीक है. सो द सबसे बेसिक अल्कीन इज इथीन. ओके, दिस इज इथीन. हाइड्रोजन बैलेंस कर लेना. प्रोपीन इज C डबल बॉन्ड C. दिस इज प्रोपीन.
Sir, propane will come under alkanes.
प्रोपेन और प्रोपीन.
The propane.
प्रोपेन अल्केन्स में आएगा.
Oh, okay.
Sir, alkanes are the double bonded one, right? No.
अबे भाई, अल्केन्स आर जस्ट
Oh,
सिंगल.
yeah. Single bonded. Okay.
अल्कीन्स मतलब डबल बॉन्ड्स और डबल बॉन्ड प्लस सिंगल बॉन्ड. ओके, ठीक है. ये देखो अल्केन्स मतलब क्या होता है? ओनली सिंगल बॉन्ड. अल्कीन्स मतलब होता है डबल और डबल प्लस सिंगल. अल्काइन्स मतलब होता है ट्रिपल और ट्रिपल, डबल और ट्रिपल, single or triple, double, single. Is there any other combination?
No.
Because double and single is impossible. That turns into an alkene.
Yeah.
So can you show all the formulas you asked us to write
Where? I mean,
for alkenes?
alkenes का कब बोला यार मैंने? अभी तक बोला ही नहीं है मैंने.
No, so you gave us that C double bonded with C.
No.
C2H4. Just ethene. Yeah, ethene.
इथीन कहाँ? इथीन का फॉर्मूला बताओ.
C2H4.
C2H4. प्रोपीन का फॉर्मूला बताओ.
So 1 minute, I'm doing it.
I have given you the structure.
Sir, the general formula you gave, is it for only alkenes?
The general formula, I mean, repeat your question.
So the general formula you gave, is it only for alkanes?
See, if I gave you CN H2N plus 2, this is only for alkenes.
Alkanes,
Alkane, cane, hurricane.
not cane.
Bhai.
Alkane, right. Okay.
Sir, I got it for propane.
C3H6.
Sir, I got it as C3 and H7.
H7 हाँ नहीं हो सकता भाई.
C3H6. it is.
Second is propane.
T3H8, sir.
C3H8 वाह. तो सबका अलग अलग आंसर आ
But
रहा है.
sir, H is
So,
H7.
Let's see. I also don't know. Let's see. देखो दो है इधर, इधर एक है, इधर तीन है. 3 4 5 6.
हाँ.
C3H6.
So the formula
C3H6,
for
yeah.
alkene. Yeah, so that I realized that.
I got my error.
got it.
ठीक है. फिर ब्यूटीन का बनाओ.
Sir, propane का okay.
ब्यूटीन का फॉर्मूला बताओ. You know the general formula, obviously you'll be able to say.
Sir, I will.
Do the next. I mean, draw the structure.
Oh.
So wait, so is it C single bonded with C, single bonded with C, double bonded with C? Is that how it goes?
If I say, everyone will come to know.
Good answer.
Oh, how we supposed to know the structure?
Send me in the group to them. Sorry, send me individually.
So I don't have your DM.
You like put like
You don't have my.
DMs.
Sir, how do we know if it's single bonded or double bonded?
एक रुको, एक सेकंड. If you don't have my number, right? ठीक है, तो ग्रुप में भेज दो, ठीक है, तुम बोलो.
Sir, if we put this one over here, won't it be like two beauty?
हाँ, वो अलग है. Don't jump. You have not reached there.
No, sir, it's because I know this from
True
last
beauty?
week.
Huh?
No.
Oh, that's nothing.
That's nothing.
That's nothing.
Okay. हाँ, गवित बोलो.
Sir, how would you know, like, is it a single bonded or bond, like, while forming these formulas?
मैंने क्या बोला था कि मिनिमम एक डबल बॉन्ड होना चाहिए एंड रेस्ट ऑफ इट शुड बी सिंगल बॉन्ड. तो कार्बन और कार्बन के बीच एक डबल बॉन्ड लगा दो और बाकी सिंगल बॉन्ड लगा दो एंड सेटिस्फाई रेस्ट ऑफ देम बाय यूजिंग हाइड्रोजन. सो फॉर्मूला इज C4H 2 3 4 5 6 7 8 H8, right?
Yes, sir. Got it.
Ah. So the general formula of alkenes are, write down everyone, CnH2n. General formula of alkenes, CnH2n.
So in the exams, do we have to use the general formula or do we have to use this?
It depends on the question. Tell me the question.
No, like, what is the formula of dash dash dash?
Do both for safety.
Okay.
Sir, I have sent for butane. Can you cross check it?
क्या स्ट्रक्चर भेजा है क्या
हाँ.
ग्रुप में?
नहीं.
कहाँ भेजा है भाई?
Sir, एक.
विजय का मिला है मेरे को. C4H8 लिखा है.
So I sent mine too. It's the
हाँ, I saw yours. ठीक है. ओके, तो ठीक है, तो फिर ब्यूटीन, फिर पेंटीन का क्या होगा? फॉर्मूला क्या होगा पेंटीन का? फॉर्मूला
C510, right?
Yeah, C5H10.
C5H10.
ठीक. So write down one information. देखो, I want to say you one more thing. कि any organic, I mean, most of the organic compounds, I am very careful. I should be very careful when I use some words. Most of the organic compounds, because I know doubts will be loading. Most of the organic compounds have two names. जैसे घर में बुलाते हैं ना, एक तुम्हारा ऑफिशियल नेम होता है, एक होता है घर पे बुलाने वाला नाम, है ना?
Yes, sir.
गोलू, मोलू.
No. So no.
Few of them. I did not pinpoint anyone. So the official name is known as IUPAC, and जो घर में बुलाते हैं that is known as common name. Okay, तो IUPAC के लिए rules and regulations है, बहुत सारे rules and regulations हैं. To name any organic compound, we have rules and regulations which we will learn. That is, I mean, and the name that we get after following rules and regulations is known as the IUPAC name. IUPAC is International Union of Pure and Applied Chemistry.
So will we remember this?
No need, man.
Oh, okay, fine.
But if you ask me some doubts which I'm not able to answer, I will call IUPAC.
So assuming you have the phone number.
Yeah, I have them.
Ma'am, sir, what is C?
Chemistry.
Oh,
I have the number because many of you ask me some doubts for which I need to call IUPAC. ठीक है, तो जो ये इथीन है ना, ये इथीन है IUPAC नेम, याद रखना. इथीन इज IUPAC. देखो, नो नीड टू रिमेंबर, मैं तुमको बताने वाला हूँ हाउ टू नेम देम. Those rules and regulations I'm going to tell you, and after that you will be able to name most of the organic compounds. It's very easy. Name is very easy, and the common name is ethylene. You have to remember the common name, because common name में कोई मतलब नहीं है, कुछ भी हो जाता है common name में. तो write it as ethylene. गंगाधर, कुछ भी ऐसे कॉमन नेम। गंगाधर भी शक्तिमान है।
Sir, so copper is the common name of the metal. So what is the IUPAC name of copper?
भाई डोंट डू दिस इन, भाई ऑर्गेनिक कंपाउंड्स के लिए बोला था, मेटल्स के लिए नहीं होता ये सब। ठीक है। So alkynes and the reason why alkenes are more reactive than alkanes we'll discuss in the next class. ठीक है, ये बस याद रखना, don't forget to ask me this because this is important.
Okay.
ठीक है, bye bye.
Thank you, sir.
Yeah.
Sir, still it was my general doubt. Sir, is there any IUPAC name for copper?
भाई मैं क्या बोल रहा हूँ, that is only for organic compounds.
Oh, okay, sir.
Copper and all these are elements. Elements का क्या nickname है? देखो, एक तो ये हो सकता है, तुम्हें याद है क्या, आयरन जो है it is named as Fe from किससे, याद है ना?
No.
एक लैटिन नेम है ना, कुछ फेरम या कुछ तो है ऐसे।
सर किसका? आयरन का है।
आयरन का है, जैसे सिल्वर का भी एजी कैसे होता है,
सर एज अर्जेंटिनम।
हाँ, वैसे ही होता होगा। हाँ, वैसे ही होता होगा। अभी मैं फोन करके बताता हूँ, ठीक है जीवितेश, IUPAC को मैं लगा ही रहा हूँ फोन।
Thank you, sir.
भाई मैं सही में बोल रहा हूँ, 11th और 12th में जब भी कोई ऐसे बोलते हैं ना कि सीधा IUPAC को फोन करता हूँ, दैट इज माय आंसर।